This is CPM Precalculus, Chapter 2, number 128. A car travels 60 minus 10t miles per hour for 0 is less than t is less than 3 hours. Alright, so part A, we're asked to draw a graph of the situation, label the axes appropriately. Alright, so we're given the speed of the car, right, in miles per hour as a function of time, right? So we know that the speed is, let's call it speed, or let's just use S equals 60 minus 10t. Okay, so that's a function of time where t is in hours, right? And we also know that we're only looking from 0 to 3 hours. And what is this going to look like? So let's go ahead and graph this. We have our x-axis and our y-axis, but here we're going to have our t-axis and our s-axis, right? This is its speed. Okay, we could call this velocity v2 if we wanted, but I'm just going to use speed for now. And we know at t is equal to 0, right? So this is 0, 1, 2, 3 hours. We only care about the first 3 hours because that's when it's traveling at this speed, right? So at t is equal to 0, let's make a little t chart so we know t and s. When we plug in t is equal to 0 into our equation, so let's say when t is 0, we know s is then 60 minus 10 times t, 60 minus 10 times t, and t is 0, so that's 60 minus 0, or just 60, right? When t is 1, let's do it for, since we have 1, 2, and 3, let's do all 3 points, 2 and 3. We know when t is 1, we have 60 minus 10 times t, and t is 1, so 60 minus 10 times 1 is 60 minus 10, or 50. For t is 2 hours, we have 10 times 2 here, so that's 20, right? So 60 minus 20 is 40. And here we have at the third hour, the speed is going to be, 10 times 3 now. And that's 60 minus 10 times 3 is 30, so that's 30. Okay, so if I draw the height here for my axis, I want the highest point to be at 60, so I'm going to go ahead and say this is 10, 20, 30, 40, 50, 60, right? So each one of these ticks up here is 10, so 60, 50, 40, 30, 20, 10, right? And at t is 0, I know I'm here at 60. At t is 1, I just go down to 50. At t is 2, I go down to 40. Right here's 40. Yep. And t is 3, I go to 30. So I look here at 30, I go across. And so my graph is linear, right? I can even see it's basically similar to the line, right? Y is equal to 60. Or I can even write the negative 10x plus 60. I'm just using the different variables. So my y-intercept is 60, just like here, it hit 60. And the slope is negative 10 over 1. Alright, so let's label the axes. This is speed here, right? Speed axis. And that's in miles per hour. And here is my t-axis, or time, and that's in hours. Okay, so that's a graph of the situation, and the axes are labeled. Here we have time, t, here we have speed, miles per hour. Alright, so part B says to go ahead and compute the exact area under the curve. Alright, so we know our curve is just going from time is 0 to 3, because in the original problem we're told 0 is less than or equal to t is less than or equal to 3. So the area under this curve is going to have this shape, right? We're going to just pull down these as the size, and here's the area under the curve. And what shape is this? Well, we can see these sides here are parallel, right? These are parallel sides. I'm going to mark these as parallel. So that makes this a trapezoid. And we know that the area of a trapezoid is equal to 1/2 times base 1 plus base 2 times the height, right? And we have a trapezoid here. The base 1 is going to be the height of this side. We know that's 60, right? Base 2 is the height of this side. And at 3, we know the height should be 30. The height, but this is the base and base. So that's B1 is equal to 60, B2 is equal to 30. And the distance between those vertical sides is the height of our trapezoid. And that is just 1, 2, 3, and hours. So to find the area, right, we can just plug in our values. 1/2 base 1 we know is 60 miles per hour, plus base 2 we know is 30 miles per hour, and the height we know we just found is 3 hours, right? And if you notice, I'm putting in the units, right? I'm putting in all the units just so we can see what cancels out and what doesn't. So that's equal to 1/2 parentheses first, so 60 miles per hour can add with 30, and that's 90 miles per hour times 3 hours, right? Then we're just multiplying 1/2 times 90 and times 3. 1/2 times 90 is 45. We still have miles per hour times 3 hours, right? If you look here, hours and 3 are over 1, right? So the hours cancels out, and we're left with miles as the units, and 45 times 3, right? Which is equal to 135 miles. Alright, so the exact area under the curve is 135 miles. If we would have used rectangles to approximate it, it would not be the exact area. So we need to go ahead and use our knowledge of the shape being a trapezoid, right? Because we know the area of a trapezoid is just 1/2 times the bases added together times the height. Alright, part C says, explain why it is reasonable to say that the car traveled 135 miles in those 3 hours. Wow. Well, look right here. 135 miles is what we get, right? So why is it reasonable? Well, we know our speed, or we know our distance traveled is just speed divided by time, right? But if we didn't know that, let's go back. We know speed is just distance divided by time, right? We know that because like our speed is in miles per hour, feet per second, some distance per unit of time. So we can solve this equation for distance by multiplying both sides by time, right? If I multiply both sides by time, these cancel on the right, and I get time times speed is equal to distance, okay? So either way, you can find out distance. So when we say distance is time times speed, if we look at our graph here, we know that here the axis is speed, here the axis is time. So if we multiply those two, it gives us our distance, right? We're looking for distance. So if we multiply these two, that's also the area, right? It's the area underneath the curve here. And so we can say distance is equal to speed times time equals the area under a speed versus time graph. Okay, so versus time, if we have a graph here, we have speed versus time. That's just how you can name this kind of a graph, where the axis, the y-axis is speed, the x-axis is time, so you just can say y-axis versus x-axis graph. So speed versus time graph. So the distance is under, the distance equals the area under the graph, and we can see that it's also, the units cancel out, equals miles per hour times hours, right, is equal to miles. And we already calculated it to be 135 in part B. So this is how we can go ahead and explain it. The units cancel, and the distance is equal to the area under a speed versus time graph. Alright, so that's going to end for us CPM Precalculus Chapter 2, number 128.